Hello, this is Stephen McNutt from Denmode.com. In this video, we're going to configure a two-level elliptic curve PKI implementation. Now, a lot of the steps and topics are already covered earlier in the series, so I'll mostly be focusing on the things that are relevant in elliptic curve in particular. Let's take a look at the stuff we're going to be working with in the network topology. So, the servers we're going to touch are the offline route for our elliptic curve PKI, and then our second tier in our hierarchy, which is going to be our enterprise issuing CA. And then finally, we're working a little bit with this guy here, PKI. He is our web server who provides the online responder as well as the Krill services. So this is where clients go to download the CA certificates for chaining validation, as well as checking the validity of certificates using the online responder and optionally downloading the Krill. Also, later in the video, when it comes time to verify our PKI, we'll want to do some enrollment. So at a minimum, we'll go ahead and enroll a router, and depending on how we do for time, we may enroll a PC just so I can show you a couple of interesting things about that. But we'll have to see how quickly we get through things. So looking at the high level overview, I just want to stop and do make one small point, and that is really important that you do a minimum of planning before you go and start configuring, because if you follow the series at all or even just browse through the listing of blog posts, it's fairly obvious that PKI has a lot of moving pieces, especially if you're going to do a two-tier hierarchy. And if you want to do Active Directory integration and be able to enroll devices and everything, really is a lot of pieces. So it's really important to plan your implementation. A lot of the things that you initially configure when you build it are, those are become the base that everything else is configured on top of, and you can't go back and change it once you've started using it. So it's really important to get everything right the first time around before you get into the business of issuing any certificates. So that's really important. So that's why I stopped to talk about that for a moment. We're not going to worry too much about the planning here because we've already been through that, and we're just going to do the build now. And the build, just again to cover the high level steps, and we've done all this before, is we're going to set up an offline route, and then we're going to set up an enterprise issuing CA, which is actually going to hand out the certificates. And once again, the reminder is the reason we have an offline route is that we're protecting the private key of our root CA. We don't want the private key of our root CA to ever be accessible. We want that ideally under physical lock and key where nobody can get to it. Then we're going to go ahead and configure the existing online responder that we've already set up earlier. We're going to create and test a couple of templates. And then finally, we'll cover some verification steps where we'll look through and make sure we didn't make any mistakes and verify that everything looks like it should. And this is really also good for troubleshooting purposes. You really want to obviously be able to look at a certificate and know what should be there and know how to interpret what the fields are. And depending on how we do for time, we may set up the auto enrollment. Again, that was covered in an earlier video. So let's start with our offline route. Okay, if you remember from the earlier steps, we're going to use a CA policy.inf file. Now, you don't have to do this, but it really makes life a lot easier. Otherwise, you have to go back and edit a bunch of registry entries. And there are also some defaults that aren't so awesome. An example would be the default templates. There's like a whole bunch of default templates. And again, to kind of rehash things as a reminder, we don't like to use default templates when we issue certificates. What we like to do is we like to copy the template and then modify the copy to suit our needs, and then issue certificates based on the copies, the duplicates that we've made. So we really don't want to use the default templates. So we're going to just make life easy. Instead of having to go and delete them all, by just flipping next a bunch of times. We're going to use this customization so that we're not doing any. And we're also, another critical change on our root CA is we're changing the accrual period to 20 years. And the reason for this would be, if you're since you're putting your offline root into cold storage, basically, if you don't do this, if you take the defaults, or you make it like every 6 months or something, if you set a relatively short CRIL validity period, what you have to do is every now and then you have to boot up the CA, and you have to create a new CRIL and then manually copy the files over to your CRIL distribution point, which is going to be the web server and your issuing CA. And I would say that that's not really that necessary. It's kind of a pain in the ass, and it's not that beneficial, because you can just do it something event based instead of timer based. And what I mean by that is really the only time you're going to update the CRIL for your root is if you're uh, revoking the certificate of one of your certificate authorities, which should be a somewhat rare event. But in the event that you do that, you would just go ahead, and at the same time you're revoking the certificate for that CA, you just issue a new CRIL. Right? So putting the CRIL on a timer for the root doesn't make a lot of sense to me. So that's why we're doing that there. And there's really not much else we're doing customization wise on this, so it's pretty straightforward. But those are just a couple things that are really nice. So I've already gone ahead and done this part. And so let's go ahead and add roles and features. And okay, features and roles, excuse me. Which one are we on? We're on our root. And it looks like it's already installed. There's really not much there. You're just clicking next a bunch of times. So now we're going to configure. And this is a standalone CA, and this is a root CA, and new private key. Okay, now this is really important. This is where we're now deviating from the norm. So here we are going to use ECDAP 384, and we'll use SHA-384 for our hashing algorithm. Now, the strongest elliptic curve cipher you can use is the 521-bit cipher. We are not going to use the 521-bit cipher, and the reason is Cisco iOS does not support it. And a big part of why we're building this is so that we can have fun with our lab and build all kinds of fun VPN things with certificates. And so we want to use something that's actually supported by our routers. So that's why we're going to go with this. So we're doing ECDSA with 384-bit keys, and we'll use SHA-384 for our hashing algorithm. This is where we get to name our CA, and we're actually going to call this Denmode. This is one of those things where you want to work out before you start configuring what you're going to name everything. We're going to call this Denmode EC root. That looks good. Next. And we'll set a validity period at 20. And generally you do like the rule of halves, which allows, so if you do like 20, then you will do 10 years on the CA certificates, sub-CA certificates we issue out of this guy. And what that will do for you is you'll be able to renew the sub-CA certificates one time within the validity period. So that's like a general strategy that's usually used. Okay, now let's come over to our certification authority and begin the configuration in earnest. Okay, so should be empty. Yep, everything's empty. So let's go to our properties, And let's look at our certificate. It's always a good idea to get in the habit of inspecting certificates after creation. So we have a signature of SHA-384. We have a 384-bit ECC public key, which means we'll have a 384-bit private key that corresponds to that. So that looks good. We're happy. And then the next step when configuring a new CA is always the extensions. And my preference is to rip out the defaults, which is what we're going to do right now. And we are going to put in our own. So first is going to be the one for the file system, which is where the krill is going to be created when we actually issue the krill from the snap-in. And that looks good. Okay, so we'll publish krills, we'll publish delta krills. We like that. And then the second one is the actual HTTP URL we're going to embed inside of the certificate. So when we issue certificates, this is going to be inside of it. So we'll include in krills and include in the CDP extension of issued certificates. So that's what we want right there. And then we're going to switch over to our AIA, Authority Information Access. Rip out the defaults. Bye-bye. Okay. And for this guy, we're going to make something. This is going to be very simple. We're just going to put in the path on our web server where we're going to store the certificate, the root certificate. And we're going to include this in there, and that's it. So those are our extensions, and everything's good. Okay. And then finally, there are a bunch of cert util settings we want to make. So let me copy those fire up a copy of PowerShell here. Okay. So this is just making our lives easier. You can do all this with Registry with like a regedit, but it's a little easier to just use cert util. So we're doing a 20-year krill, so that way we don't have to go through the hassle of booting this thing up to issue new krills, because really the only time you should ever have to update the krill is when you're revoking a CA certificate anyway. So you would, if it doesn't make any sense to have like a timer on it. You should just, in my opinion, you should set the krill on the root CA to be the equal to the validity period of the CA certificate. So this is all good. And we'll do 10 years for certificates that we issue. And that looks good. So we'll go ahead and run these, create these settings. Okay, I think we're good. Let's restart the service just one more time, just for giggles. We want to make absolutely certain these settings have been read in. Copy. Okay. So we should be good now. So this guy should be ready to issue certificates. So let's flip over to our enterprise issuing CA and configure him. Oh, I missed a step. A couple steps. This is why you write everything down, right? Publish krill. So this is done. This is done. Publish krill. So let's publish the krill. So the easy way to publish a krill is you just right click on revoke certificates, all tasks, publish. You can also do it with certutil from the command line too. Okay, cool. And that krill and the certificate should live. This is under system 32. Serve, cert enroll. Okay, here we go. So these are just some old ones. Which one is the one we want? This one is from when I've been playing around before. This is the one we really want. Rename this later. Okay. Yeah. So there's two files here we care about. This is the root certificate for the CA, and then this is the krill we just created. So we need both of those. And I think I may have to temporarily give this guy. Yeah. Like 1032.891. So we're going to need those on our enterprise CA. We also need to put those on our, and these are, you'll notice these IP addresses are not the IP addresses that you see on the diagram. That's because I put a second NIC on the machines. This is sort of the out of band management. Okay, so we're going to take these and we need to copy these here because this is where we configured our CDP fields and our AIA field in our root certificate to point to this location, so we need to put the files there. And we need to rename this to what it's supposed to be. And we can double check that. So this is like a quick verification you would want to do before moving on, and that is we're going to look inside the certificate. That's fine, but we'll have to verify this later when we've issued the CA certificate. So let's flip over to the subordinate CA. Mark these as complete. Okay. So now we're on to set up enterprise issuing CA. It's this guy. And I'll just step through it's the typical add roles and features, service selection, server roles, and then you'll see I've installed two things: the certification authority web enrollment. Okay, so what's different between this and how I set up the RSA PKI? And that is we're not installing network device enrollment service. Why? Because NDES does not support elliptic curve certificates. Elliptic curve certificates do have an in-band enrollment method, standardized in-band enrollment method. It's called enrollment over secure transport, or EST. So this goes out like a white paper showing you how to do it using an open source tool, and I do believe recent versions of ICE allow for enrollment over EST, and so consequently I may make a video showing how to do that. So that's why we're not installing that though, because it's not relevant for an elliptic curve installation. So that's already done. I just threw the bits down. So now we'll go to the important part, which is the configuration. Also, note I did this, and this is just, we don't want to junk up the installation with a bunch of default templates we're going to delete anyway. So I fixed that ahead of time with the CA policy.inf. So first we'll do the certification authority. And this is an enterprise, a subordinate CA. And again, this is a really important step. If you do this part wrong, you have to start over again. There's no fixing this if you do this wrong. So we're going to use a 384-bit key because that is the longest elliptic curve key iOS supports. And then we need to go back and look at our documentation to see what we're going to call this guy. And we're going to call him Denmode ECA. That sounds reasonable. Like this. Paste. There we go. Nice. Yes. Okay, so we're going to save this to the root. This is our certificate request. That's fine. And that's because we have an offline root. So we're going to be doing a little bit of fiddling around with text files here, just like we did with the other one. So we come over here and there's our request. So let's just open this in Notepad. As you can see, it's just a text file. Not so bad. And we could just copy the request file because I think we already have it. And we can just go here and go to our $$ share, and it's not there. That's odd. Okay. Oh, that's because I'm looking at myself. Let's try this one. There's our request. So let's copy this to the root CA. Pretty straightforward. Okay, now we're going to process the request. So we're back on our root CA in the certification authority snap-in. Right click all tasks, submit new requests, and we'll just go pick up the request we copied off of that we created with our shiny new enterprise CA. Put that on the root. So we just go there. And there's our file. And it should now be in the pending request folder. It is. So let's go ahead and issue. Okay, so we've issued the certificate. So next to the root CA certificate, this is the second most important certificate in our PKI. So we need to stop and take a look at it and inspect the important fields to make sure everything is what it should be before we move on. Okay, so that's cool. We're doing SHA-384. Issuer, okay, that looks good. Okay, validity, so it's valid for 10 years. And that looks good. And this is a 300, this is the public key of the certificate. So that's cool. And so one thing I do want to point out really fast is the digital signature can actually be different than the public key algorithm. So for example, you could have like an RSA public key that's been signed with an elliptic curve signature and vice versa. So you could have like an elliptic curve public key that's been signed with an RSA key. They don't have to use the same cipher suites. And that I know that can be very confusing. So, and it is. So I just wanted to mention that. And okay, so we're cool. Everything looks good. Okay, so the two are really important fields we need to make sure are correct are our CDP field. So our CDP field points to this URL. So we need to just grab this and test it. And that's probably not going to work on our offline route. So let's come over here and test it on another machine, which is our, I think this is our web server anyway. So we should, okay, that's good. So we're able to just paste the URL in the CDP field into a web browser and retrieve the krill. So that's perfect. So that's good. And then let's do the same thing with, we'll go look at our authority information access. And this is the same idea, which is, can we take this URL that's in this AIA field and use it to retrieve a copy of this CA's certificate? Because if you don't, you will get chaining failures. Your clients will not be happy. Try that again. Okay. And is it working? I wanted to open it. Open. There it is. Cool. All right. So this is fine. It's just saying I don't trust this route, which is okay because we haven't done that part yet. And that looks good. Okay, so we were able to download the root certificate. So we looked inside just to recap what we just did here, so it makes sense. What we did was we inspected the certificate of our enterprise issuing CA. So this is the certificate we issued from the root, and we're just double checking the CDP and AIA fields to make sure that they're valid so that we don't have any problems later. So it all looks good. So now what we're going to do is we're going to export this certificate. And we're just going to do it the easy point and click way. Just bring up the certificate, copy to file. We're going to use base64, which is the privacy encrypted email or PEM format. And Denmode dash UCS ECA, Enterprise Certificate Authority. Save. Next. Finish. Okay. So then let's grab that. And we need to go and give that to our enterprise CA, which is this guy here. So we'll just drop that off in the root as drive. And then we'll hop onto that server. Okay. We'll do that in a minute. So if we go to bring up the certification authority. Okay. All tasks, right click all tasks, install CA certificate, all files, and This is us right here, Denmode EC ECA. So that's the processed request. That's the issued certificate from the request. Do I wish to trust the root certificate? Okay, so I missed a step. So let's back up. Before I do anything more, let's go back and look. What do we have here? Create CA policy. Okay, did that. Did we publish the root cert to AD? Did we add the root cert and create the local store? No, we did not. So let's do that. So let's grab our handy dandy cert util commands, pop them in the notepad, and let's make sure our file names are correct. Okay, so Denmode, it's actually this. That's what it's called. Denmode EC ECA. Oh, that's the root, not the enterprise. Denmode EC root. So let's start by renaming this. Okay, there we go. So that's our root certificate. So we're going to publish that into Active Directory. Remember how we got that error before from our PKI server about the root being untrusted? Well, this will fix that because that's a AD joined machine, and so this will get pushed down through group policy object because we're going to publish it into Active Directory, and then the domain default GPO will push this down. Get the file. What's the file extension? CRT. And that's correct. And then this is just to install the krill. So we're publishing the root certificate to AD, and then we're also publishing the root certificate and the krill to the local store. So these are the three commands we're going to run. Okay, looks good. So now, when we go to install our certificate, we should not get a warning. And we did not, so that's great. Okay, so let's go ahead and start our CA. Okay, sweet. All right, and go look at the properties. Let's inspect our certificate. So this is a certificate that the root issued to us, which we've already verified the certificate was good before we even installed it. So this is all going to be the same. So we tested these. These are the really important ones to test. We checked our validity periods, tested our AIA and krill entries to make sure that they were correct and that we had the files installed correctly on the web server. So now we're going to go through the extension configuration on our issuing CA. It's only slightly more involved. Let's just go through the ripping out part. This is like the funnest part. I love the ripping out part. Yay, all the config is gone. So now we're going to add some CDP entries to our enterprise CA. Ah, that reminds me. Oh, well, let's configure this first. Okay, so first step is going to be our file system, our local file system. So put this in. Now I want to stop and mention something really fast. what are these %8, %9 things? I'll put a link where you can bring up the website on the blog, but these are variables that correspond to this. And so what they mean is like a delta krill name suffix delta krill allowed is actually what %8 and %9 are. And so what that does is that it automatically generates the delta krill with the name with the plus symbol on it. If you don't do this, then you have issues with the delta krill. So you don't have to use the variables if you're not going to use delta krills, but if you're going to use delta krills, got to have those. So just in case you were curious. So let's see. And how do I know this? Because of course I didn't put those in one time and built things up, and I had all kinds of problems, and I was ripping my hair out, and then I found out what was going on, which was my delta krill had the same name as the main krill, so the delta krill was overriding the main krill, and I was getting all kinds of crazy errors with all the things. So this looks good. And then yes, publish krills, publish delta krills. And then the next one, this is the one that copies the krill to our web server automatically for us. So when we publish krills, they go to the web server, and they should have the correct name. So we'll double check that, but the name that gets of the files that get generated on the web server, they need to match what's in the extensions field of our issued certificates, or we'll have problems. But we'll verify that later. So we're publishing krills, we're publishing delta krills, and that's all we need for that. And then we're going to finally have the one that's going to be embedded inside of our certificates. And again, this is the purpose of this, is so that when a client that has a certificate issued by us presents a certificate to another client, that client can look inside. At first, it'll check for the online responder in the AIA field, but if it's not there or it doesn't support it, it will check the CDP field in the certificate, and it will take this URL and retrieve it, and it will grab the krill, which is just a list of serial numbers, and it will make sure that the serial number of the certificate does not show up in the krill. So it's just a validity check. So this is including krills, including the CDP extension of issued certificates. Okay, almost done. So now we're going to flip over to the AIA, and we're going to add two things. First, we're going to add in our root certificate. So this is the root certificate of the Enterprise CA, right? It's pretty straightforward. And we're going to include that in the AIA extension. And by the way, don't check this. I've done that before. This is a completely different thing. You don't, because if you put that there, then clients will check this because it'll think that's a place for the URL for the online responder, which is obviously we don't want. And then copy. And then we're going to add the URL for the online responder. And again, this is really confusing. It's not user friendly. So if you check this, include AIA extension, if you remember, I screwed all this up when I built the RSA CA. So we don't want that, because it's going to think, oh, client's going to think, oh, that's where I go to get the certificate for the CA. Nope. So we just want to check just that and just that alone. So that's what we're doing. And then click OK. Okay, so let's check our task list. Okay, so that's done. Done, 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 done. Highlight done. Okay. Run scripts. Okay, so let's grab our script. And again, this is just a bunch of settings that are setting up some fields for us before we start issuing certificates. It's a lot easier to do it this way than regedit. So pop these in. So we're setting our krill to 2 weeks with an overlap period of 12 hours. And the certificates we issue can have a maximum validity of 5 years, but we'll do 1. And since the certificate for the CA is good for 10, it means that means that you could actually have a 5-year certificate and then renew it one time. Pretty straightforward. All the ugly little things that you just do it once and then you never have to think about it again. Okay. Don't think our cert service restarted. So we're going to do it ourselves. Okay. Okay, so that's done. Let's check our task list. Aren't lists awesome? Okay, run scripts, done. Okay, next step, copy enterprise, cert to web server and rename. Okay, so one thing we can do to just to validate before we do anything else is let's do this. Let's go over here. I'm going to change the order a little bit. What we're going to do is we're actually going to publish acryl. And then we're also going to issue ourselves a certificate. So let's, and I'll show you why. This is like a little more involved, but it's just kind of hard to summarize in a list. And you can do it the other way. But so remember, we never use a default. We just take an existing template and duplicate it. General, and we'll just call this dense mode. Dense mode, EC user. So we're going to do 1 year, and we are going to change this. We are going to go all the way to version 4 template. And so something I want to mention is the web enrollment only supports up to version 2. So when you change the compatibility settings, when you go in the web enrollment, you'll notice the certificate never shows up. So that kind of sucks. So I'll mention it again when we get back to that point. So let's go over to cryptography and key storage provider, and yeah, rockin' hash. So we're going to make this an elliptic curve template. Yeah. General. Yeah. Yeah, man. Looks good. Okay. And we'll come back and play with the security later. And we'll go ahead and issue the template. That was another thing we changed in our CA policy to INF. There's no default templates like in a stock installation. I prefer that. You don't want to have like a bunch of crappy templates. Never use default templates. I can't say that enough times. Dense mode, EC user. There he is. Okay, so it's there. So now let's see if we can't get a certificate. See if it shows up. Ah, there he is. Sweet. Enroll. Request denied. Details. Ah, I know why. Every time. So we got a couple things to fix really fast. So pardon the construction dust. Let's come back to our template. Okay, so subject name. Nope, don't need that. Don't need that. And then let's come back to cryptography. Okay, minimum key size 384, that's fine. So let's try it again. Okay, EC user. Yay! Awesome. Okay. So let's take a look real fast, and we're just going to inspect the fields. And let's see. Look at this. Yeah, dog. ECC certificate. Okay, so this is what we really care about. So this is fine. Okay, so this is what our krill, this is the name our krill needs to have. Okay, and then if we look on our AIA, this is the file name that our certificate needs to have, right? So let's validate let's take a look at the share on our web server and make sure that everything lines up. Let me see. 10 dot. I forgot. 8.89 $. Here he is. Okay. So we issued the krill, and that's this here. So ECA for ECA is short for Enterprise Certification Authority, and then the plus, that's our Delta krill, and we can see those were just issued. So when I went to publish the krill, right, that's the timestamp changed. So if we were like to come back just to show you, okay, so like right, see how it says like 548. So if we come over here and do all tasks, publish new krill, and if we refresh this, see, it just changed to 553. Cool. So we know that's good. And so Denmode-EC-ECA.krill. Is that what was in our certificate? Let's go back here and take a look. Yep. And let's just make sure. Again, this is just, it never pays to go over, it never hurts, excuse me, to go over the top with your verifications when it comes to this stuff. Do not short arm your verifications when you're first setting up a PKI. Just save yourself the trouble down the road and just verify the crap out of it so that you know absolutely without a doubt it's working. So it downloaded. Okay, cool. So again, the revocation list, it's empty, but all it really is, it's just a list of serial numbers. So when you revoke a certificate, its serial number goes into the krill. Okay, so that's awesome. So, and our krill is copying up to our server, and it's got the correct name. So that means everything's configured just exactly how we want it, and it's valid. So next is we've got to go put the certificate up there. So let's do that. So we have our certificate because it was issued from the root, and so that's this guy here, and it needs to have this name right here. So we'll copy that. Let's not leave my crappy typing to chance, like that. And then we'll copy that over to the PKI folder on the web server, like this. Okay, so now you know what we're about to do, right? That's exactly right. We are going to verify this, that this AIA field is correct. So we're going to come over here. Okay, that's not good. I've got the 404. What happened? Wrong file extension. Good old Windows. See how it's hidden from view? Doesn't that suck? Okay. Just click that. Did that fix it? There we go. Little landmine action for you. I'm glad we saw that. So because if you didn't know about that, it might drive you crazy trying to find it. Okay, cool. It's working. Beautiful. Look at that. Woohoo. So what do we know now? We know that both our root and enterprise CAs, that our CDP fields are good, and that our AIA fields are good. Our cipher suites look good. Our naming conventions are on point. Everything looks perfect. So we're just the validity periods. It's work. It just makes me want to cry. It's beautiful. So let's come back to our checklist. Okay. Done and done. Okay, so what's our next step? Online responder. Okay, so let's do that. So let's come over to the online responder, which is this guy. So we can already install the online responder when we built up the RSA certification authority. So let's just bring up the management tool. And unlike SEP, the certificate enrollment, where you have to put it, you have to have a different server for each one. OCSP, you can serve multiple CAs. You can serve like a ton of CAs off of one OCSP. So we are going to add a revocation configuration. It's a mouthful. So we'll call this Denmode EC Enterprise CA. Okay, cool. This is going to fail. You know why? Well, no, because the certificate template should actually be in AD. Let's see if this works. Because we actually created the certificate template and published it in AD when we built the RSA CA. But if you were building this from scratch, it wouldn't be there. It's this guy here, this OCSP response signing certificate. We built this in a prior video. So if you're just watching this video and haven't watched the prior videos, you have to create this certificate. So we'll go look at the template real fast. So we took this OCSP response signing template and copied it, and then there's a permission you have to set for this to work. Let's see if I can get this thing to come up. Come on. Okay, so while that's thinking, this is what happens when you have underpowered virtual machines. Okay. While that's happening, let's test it and make sure it works. Okay, so there's our EC CA. So we're going to select him. And if everything's correct and all the configurations are correct, this should basically be automagical. Yep, and that's going to try to auto enroll. And we'll try to enroll from our EC CA. I don't know if this is going to work. No, it doesn't. Okay, so we have to make a new template. We would have to make a template that this guy can issue from, but we're not going to worry about that. Let's just use the RSA template. I mean, there's no need to get overly complicated about it. Why recreate it? Okay, so we got errors. That's always fun. Denmode.com. You know what? Let's just grab it out of the certificate just to be on the safe side. Certificates. Okay, that's for our RSA CA. Let's look at an issued certificate. Come on. There we go. So what he's looking for is the krill distribution point, this guy here. And that's because that's what the online responder does, is the online responder uses the krill. Like that. Okay. Let's see what we get. Hey, look at that. It's working. Sweet. Kick ass. All right. We're stoked. Okay, so let's go look at our done and done. We are finished. Okay, create templates, issue templates, enroll devices, inspect certificates. We've been kind of doing this all along. I'm going to circle back to that. Let's run this, and let's see if we have any errors in our configuration. So we can do this basically from any domain joined machine. This is a terrific little tool. It'll let you do a lot of stuff. It's awesome. Okay, so it says we've got an error. What does it not like? Doesn't like AIA location number 1. Why not? Because we don't trust the root. Okay, that's easy enough to fix. It's there. I'm not sure. I think it could. I'm not sure why we're getting that message. Refresh. Okay, now he's cool. Well, we published our certificate into AD, so he should. Okay, let's do this. GP update. If I can spell GP. And actually, we have to run this under. Let's run this under administrative or credentials. Or not. Come on. Bloody hell. So what I'm doing is I'm forcing a group policy update. And I think I can also do like certutil / there's a certutil command too. But this is the heavyweight way of doing it. Okay, cool. So what we did is we just forced a GPO refresh, and it acquired the information about the root certificate, where to locate it and download it from the group policy object, and it went and grabbed it from the domain controller. So now we're cool. So why is it still unhappy? Because it says our CA is offline or unavailable. Why is that happening? Okay, so I poked around a little bit, and it was definitely a name resolution issue on the web server that we were testing. So it was not a configuration problem. It was more just I'd been labbing some other stuff and was changing a bunch of things around and didn't completely clean up all the floor shavings before I started over again. So I went and fired up PKI view here, and we can see that everything validates. If you remember, there's a configuration error where we defined something incorrectly with our RSA, even though it doesn't really break anything. You would never want to put it in production. But we learned from that, and we did a little better job when we set up our EC hierarchy, and we can see our root and our enterprise issuing CA are clean, 0 errors. Everything is perfect. Everything checks out. It's exactly how we want it. So let's take a look at our task list and see what we're down to now. Okay, so we've actually already created a template and issued a template and enrolled and inspected. So really, probably the only thing left to do is that we really want to do, since we're already over an hour now, is so that's done. Is let's do a router. So let's do a elliptic curve certificate for a router and make sure that it works. And so for starters, we'll take a look at the templates we already have and see if that will actually work. So here's our Denmode router. Let's take a look and see what that guy is. Template name, cryptography, Microsoft RSA. Yeah, I think that could be a problem. Why don't we do this? Let's try this and see if we can actually get it to work. We'll use can use any provider. Let's do that. We'll just open it up, let the service provider figure it out. We need to drop the minimum key size to 384 bits because remember we're using elliptic curve keys. So this should work. We should be able to just use the same template. Okay. Security. Okay, looks good. And yep, this is all fine. Okay, so we just made one small change, which was we shortened the key length and we're allowing any cryptographic service provider. So we're giving ourselves some flexibility. So let's try to issue a certificate. Okay. So let's hop on a router. Okay. Okay, home stretch. So first we got to create the keys. Show IP domain name. Okay, cool. So we'll do crypto key generate. This time we're going to do EC. And we'll do key size 384. Label, we'll call this that looks good. Okay, cool. So now we'll do crypto PKI trust point. I can spell. DM EC CA. We'll do enrollment terminal. And we'll do I think it's EC key pair or EC key pair. Then we use our label, which was this. And so first steps. So let's authenticate. Crypto PKI trust point. Authenticate. CA. Authenticate. Did I do something wrong? Crypto PKI authenticate. Authenticate. Okay. So let's go grab the certificate. It's this one. Just open it up with Notepad. Grab it. Paste it in our terminal. Okay, so we have just a clock issue here. Okay. Okay. This is normally show why this is why you want to run an NTP server on your network when you're using certificates. So we're just gonna fix this quickly. Clock set. August. So we'll do August. We'll do 15th. I'm having fun. Okay. Yes. Okay. Now let's try to enroll. Crypto PKI enroll. DM EC. DM EC CA. No. Oh, you know what? I didn't configure the subject name. So crypto PKI trust point. Crypto PKI trust points DM EC CA. Oh my gosh. Subject name. Common name equals R1 dot densemode.com. O equals dense mode. OU equals IT. Now let's try to enroll. Enroll DMC CA. No, no, yes. Okay. So here's our certificate request. let's see if we can host enroll this router. Request a certificate. Okay. What am I logged in as? We need to issue a certificate or a template to issue from this CA. That's what I did wrong. So let's add our dumb DM router. This guy here. Okay, now it should work. Yay. Okay. And we got a certificate. Sweet. Okay. Save as R1. Folder. Ah. Okay. So let's grab our certificate. Now let's see if we can finish the enrollment crypto PKI. Import DMECCA certificate. Okay. Yeah. Show crypto PKI certificates. Okay, so let's take a look at what we got here. So this is our first one. Okay, this is a certificate that was just issued. So here's our serial number. And we can see the Enterprise Certificate Authority issued it for us. And it used the subject name information we put in our request, which is pretty awesome. Here's our krill distribution point and all the fun stuff. So that's an elliptic curve certificate. Let's do the verbose so we can see the cipher suites. Okay, here we go. Signature algorithm SHA-384 with ECDSA. Public key algorithm 384-bit elliptic curve. Rock and roll. So let's come back over to our task list. And okay, that's done, done, done. Since we're already at an hour and 13 minutes, the auto enrollment, you can go and look at the other videos to take a look at that. I have a video just on auto enrollment, so we don't need to do that. But so there you go. So we now have two complete two-level CA hierarchies. We have an elliptic curve hierarchy. We have an RSA hierarchy. So this means we are prepared to support both any existing clients, but we're also in a position that we can now begin to roll out Suite B cryptography and next generation cryptography using the elliptic curve certificates. They use much smaller key sizes. It's much less computationally intensive, and it's really just a better situation all around. And so there you go. That's a state-of-the-art PKI infrastructure using both kinds of cipher suites. And I hope you enjoyed this video series. I'll probably come back with one more video with just kind of a wrap-up, just to tie up any loose ends or anything. And thanks for watching. If you got through this entire video, you're an awesome human being, and I sure do appreciate you. So I'll take care, and I'll see you at the next video.